And the issue has to do with genetic engineering, and that there was some concern that when pollen of genetically engineered corn would cross-pollinate nearby non-engineered corn, that you would get a certain amount of that transgenic material showing up. Now, corn is designed to spread its genes. We know that because the male and female flower parts are separated, and a single tassel can have 1 million or 2 million pollen grains disseminated by the wind. So the question was, and this was especially of interest in Boulder County, how far does corn pollen travel in Colorado and cross-pollinate other corn plants? Now, I knew from my work on this pathway that blue corn is dominant to yellow corn, and that the blue corn trait would show up immediately after cross-pollination. You wouldn't have to wait until the next generation and grow up the plants. So it seemed like it could be a really handy trait for this purpose. So what we did this over several years, is to grow an island of blue corn. This was about 1 acre or 2 acres, surrounded by a big field of yellow corn. Several transects, each dot represents 10 ears that we harvested. And here's our representation of our results. Here are the 2 parents, the blue and the yellow. The first row of yellow corn adjacent to the blue was almost 50% cross-pollinated. And isn't this great? You can see your data right there. Just pull that up. So that was no surprise. We know that that's how corn operates. But then it drops off really quickly. So 14%, at 150 feet, less than 1%. 600 feet, very, very low rates of cross-pollination. When we graph this, and this is what we saw over and over again, is that cross-pollination starts off very high, drops quickly, and then a very long tail. So we could predict this part pretty well, and we could identify a distance, in our case 150 feet, where you would predictably get cross-pollination less than 1%. What's really hard to, is that 10? Okay, I gotta hurry up. What's hard to predict is the tail, because that could be almost a random event. So this led the county commissioners to determine a 150-foot buffer distance when corn is grown on open space land. So just a few comments about the future of corn. To meet projected demand, the yield of corn is going to have to increase substantially, 30, 40, 50%. Improved drought tolerance and nitrogen use efficiency, those are really 2 of the biggest challenges for corn breeders in Colorado as well as the rest of the world. There are some resources, however. One is the recently completed maize genome sequence, about 3 billion bases, and also this wealth of genetic diversity we have, and a wealth of genetic tools to help achieve these great challenges. So thank you very much.
So ask yourself, if you're a Native American and you have corn on the table, what do you want to eat it with? Well, our next speaker, Mark Brick, who got his doctoral degree from the University of Minnesota and is a member of the Department of Soil and Crop Science, is a dry bean breeder. Maybe that gives you a clue to what the Native Americans decided to do. I will start the timer and ask you to, oops, we got it. I should have done that. I'm being a bad moderator. There you go. My wife would say, moderator, extreme moderator. There you go.
Thanks, Henry, and it's a pleasure and a privilege to be here. And you can see the passion that most of us have for our work. It's all pretty easily displayed. And it's good to educate people about what we do. I go around the world and people say, what do you do? And they say, I'm a bean breeder. And they scratch their head and they say, you're a what? You know, so it's good that people understand what we do. I'm going to talk about origin and the importance of common beans in the world and bring it back home. So I'm going to tell you where they come from, both genetically and historically, and then I'm going to tell you where they come from when you eat them off your plate. So common beans come in lots of different forms and shapes. They come as bush beans that you might grow in your garden. They come in climbing beans that you might grow in your garden, like Kentucky Wonder and some of the other wonderful ones. They come in dry beans, such as pinto beans, and northern beans, and navy beans. They come in intermediate growth habits. They come early, they come late. Just about any kind of variation you can think of is seen in common beans. I'm going to share some of those with you today, but not all. So let's talk about the origin of bean. Actually, most people think, and until about 7 years ago, that dry beans originated, it was unknown where the exact origin was. It's only been in about 7 or 8 years ago that Paul Gepft at UC Davis and some of the people at the International Center for Tropical Agriculture in College Columbia have actually found the origin, or using molecular tools. And that origin is, here's the ancestral origin, is in the area of Peru, northern Bolivia, southern Ecuador. Okay? And there are some wild species there that are unique to everything else, and molecularly we know that those are probably the origin. And that occurred millions of years ago, where they evolved from relatives of soybeans and cowpeas, things like that. Well, since wild beans originated from there, they were eventually, there we go, they were eventually transported to Middle America and throughout South America. And they were then what's called domesticated. That is, humans selected beans that had larger seed, earlier maturity, specific shapes and sizes. Okay. So this variation looks something like this. The Indian types have larger seed, the Middle Americans have smaller seed in different colors. I just realized this is going backwards, isn't it? Yeah. I looked at 8. Oh my God! I got 2 minutes to go. Okay, thank you. I'll calm down. So the large seeded type are the Andean types. Things that you would know is light red kidney, dark red kidney, white kidney, cannellini beans, and some of those. There are types that we don't produce here in the United States that you wouldn't be familiar with. The Middle American beans are like navy beans, red beans or small reds, pinto beans, and great northern beans. So they were domesticated independently in 2 parts of the world after the wild beans separated. Archaeological records show that beans have been cultivated for at least 8,000 years, and probably longer than that. And in the archaeological records, we see these graphics that Native Americans produced. And here you have a individual praising worshiping, so to speak, corn and beans as part of their gods. And you can see, here's your corn, and there's your beans. And this particular artifact, I don't know the exact date, but it's thousands of years old and was found in Mexico. So we know that we've cultivated and consumed them 8,000 years ago. More recently, we know that Anasazis in southwestern Colorado cultivated beans as long ago as 12 to 1,300 years ago. Some of you may be familiar with the Anasazi bean that you can buy in Safeway and other places that was actually cultivated by them and is shown here. We know that the Middle Highlands of Mexico, there were the Mogollon people. This is about 1400 AD, a little later than the Anasazis. But they cultivated beans all the way from the highlands of Mexico up into Anasazi and into Utah and Colorado. We know that pinto beans and great northern beans were cultivated by Native Americans when we got here. So we didn't invent beans. They were cultivated, they've been domesticated, and they look very similar as the ones we produce today. Okay, so how widespread were they cultivated? Well, they were actually